the input file descriptor, and the other one is outfd, the output file descriptor. Then I define a function called pump, and in this case it should return a void pointer as well, but I missed that part. And all pump does in this case is to get into an infinite loop or close to an infinite loop until we have end of file or the read operation fails. All it does is to read one single byte, but where it's reading from is coming from param. Param is, in this case, is actually useful because what I do is I typecast param to a struct pump pointer first, which then I can dereference to the member called infd as well as the member called outfd. I use one to specify the file descriptor for the read operation. I use the other one to specify the file descriptor for the write operation, which is basically just reading a byte, echoing a byte, reading a byte, echoing a byte, just like that. And as long as I can read exactly one byte from the read operation, I stay inside the loop. Okay? Which is not really the best thing to do, but just for illustration purposes, it is fine. The main program in this case will have basically 4 file descriptors, pair 1 in, pair 1 out. So each pair is basically defining the input part and the output part of a pump. So I have 2 pumps here, one defined by pair 1 and the other one defined by pair 2. I also define 2 pumps here. Basically, the initialization here is somewhat redundant because when I use open, I could have used pair 1.infd to store the result of the file descriptor, but this just kind of spells it out a little bit more. What is interesting are these 2 calls. Instead of using pthread create only once, I use it twice. And if you look at the parameters that I pass to the pthread create calls, the first parameter is different because they are 2 different child threads. So I need to store the ID of the thread IDs into 2 different thread types. So that part is easily explained. This one here means that we are not using anything other than the default properties of threads when they are created. This one is interesting because I'm using the same subroutine for both threads. In other words, a subroutine associated with a thread is like a program associated with processes. The same program can be used to spin off as many processes as you want, and for the same reason, the same function as an entry point can be used as the entry point to spin off as many threads as you want. The last part is also important because the address of pair 1 and the address of pair 2, which are basically struct pumps, they are also passed, and in this case they will be casted to a void pointer before they are passed to pthread create. But they basically will be passed to the respective threads using pump as the entry point. So this is how I can create 2 child threads, each one also using pump to define the logic of what I need to do, but they will get a different param. Each one will get a different param. In other words, the param will point to a different pump structure, and as a result, each thread will be reading from a different infd and they'll be writing to a different outfd. Is that making any sense so far? Okay. So in this case, I make sure that both of these are returning zeros, which means I successfully create these 2 child threads. And right after these calls, the main thread can now perform whatever operation it wants to do, or it can just sit around and wait. If it decides to sit around and wait, or after doing whatever it's supposed to do, then we have 2 join operations. The first one to join with pump 1, the second one to join with pump 2. And if both of those are also successful, then we have the 3 threads basically merging back into one single one, which is the main thread. And then the main thread can continue to do whatever processing it wants to do. There's not much error handling in this case, other than just checking whether it is done correctly. So you can add additional logic to do error checking. But it does illustrate that in this program, in this particular process, we don't have any select calls, and yet it will be able to handle a bidirectional pump. So the big question is this easier than using select? For simple programs like this, maybe not. Okay, because you really don't have a lot of states to keep track of, other than which byte did I read from this input and which byte did I read from that input. That's the only state you have to track when you have a simple data pump. But on the other hand, if you're doing any type of complex processing, then the state information associated with the program can be very complicated, and in those cases, doing things using select can be very, very problematic. Any questions about this program and how this program is related to your homework assignments so far? Yep.
Are we required to rewrite our client using select, and or are we allowed, or using pthreads, and or are we allowed to?
Well, let's see. We have 2 more days to go. If you want to use pthreads for your Socket 4 assignments, go ahead.
So when you pass pair 1 and pair 2 to the pump functions, those are modified in pump. They're also modified in main, right?
Say it again?
If they're modified in pump, then it doesn't look like they are here, but if they were, they're also modified in main, correct? Those variables are shared since they're passed as pointers.
That is correct.
Yep. So they're modified.
That is correct. So if I have to draw a picture, which is a little bit interesting in this case.
Not only are they modified, they're modified at the same time.
Okay, so main has its own stack, right? So main has its own stack, and since a stack grows down, we'll just say that pump 1 is here, pump 2 is here. Okay? So we're going to say pump 1, pump 2 as data structures. And they have some other miscellaneous stuff down here. So at one point, I spin off to one thread, and at another point, I spin off to another thread. So at one point, I have 3 threads. I have the main thread itself, and I have one instance of pump. But this one points to the first data structure.
But does it have a new stack?
Yes, it does have a new stack.
So how come it doesn't point to that address in its address space?
Because these 3 stacks, they all exist
in the same address space?
In the same address space, and they can still see each other.
Gotcha. So they just have their own stack, but they're same address space.
Yep.
In one process.
In other words, they can corrupt each other if they want to.
Okay.
So in this case, you have this is the other pump's own stack, but the parameter of this guy would point to pump 2 as a data structure.
Okay.
So that's why these 2 pumps, even though the code is identical, they will be dealing with a different pair of file descriptors.
Okay.
When they merge, okay, now when these guys merge, I think this guy will merge first, and then this guy will merge second. When they merge, the stack should go away as well. They should be deallocated by the pthread join operation.
So it's not only global variables that are modified, then it's also variables that are passed.
Oh yeah. The heap is also shared. The heap, the stack.
So there's only one heap. So
there's only one heap. Yes. Okay. Dynamically allocated memory will also be shared. Yep.
If those inFDs or outFDs are modified in main, after the thread is created, the thread will then proceed to read from those updated FDs immediately, and vice versa if they're changed.